Hello everyone, welcome to this new series of videos based on Laurent series. This is going to be a part 1 video. We will be covering the basic theorem of Laurent series and we will see how partial fraction method can be used to expand a given function in various boundaries which has been defined for us. Come on, let's get started. Laurent's theorem. If f of z is going to be analytic on two concentric circles is one that has center to be the same, and there are going to be two circles over here, one which is going to be called as C1, the other one which is going to be called as C2. Let C1 has radius to be equal to your R1. So from the center to the outer line, so this is going to be my radius, this is going to be my R1, and this from the center to the smaller circle is going to be my R2, and I have it in such a way that my R1 is going to be greater than that of R2. The center is going to be my A is going to be the center of the circle. So the function f of z is going to be analytic in the boundary C1, in the boundary C2, and in the annular region. What do you mean by annular region? Is the region between these two circles. So it is also going to be analytic in the portion which is going to be bounded by these two circles. So it is also analytic in this region which is in between the two circles. This is how we refer it as R. So for any value of z in R, then the expansion of the function f of z can be expressed as the summation of two series, summation n varying from 0 to infinity, an z minus a power n, and plus summation n varying from 1 to infinity, bn z minus a by n power n. So notice that the first series begins with 0. It has positive powers of n of the factor z minus a. So this gives rise to positive powers of your z minus a, and this part, which is the first part, is called as the regular part. So what do we mean by a regular part? Is the part of the series that contains positive powers of your function f of z. Now notice the second part begins with n is equal to 1, because we have a constant and then positive powers and then generated by negative powers. So we include the constant over here as n equal to 0, starting with the positive terms, and negative term begins with n equal to 1 to infinity, bn, denoted by the denominator contains z minus a the whole power n. So this generates the negative powers of your function, and this is referred by the name principal part. So keep in mind, regular part contains positive powers of the function f of z, and the principal part contains the negative powers of f of z. Now there are going to be two more quantities which are involved in the formula, which is called as an, the other one called as bn. They are called as the coefficients of the Laurent series. So how to get those coefficients? These coefficients are got by the formula 1 by 2 pi I integral over the curve C f of z by z minus a power 1 plus n into dz, and bn is 1 by 2 pi I integral over C f of z divided by z minus a whole power 1 minus n. Notice the change over here is it as 1 plus n, and over here this bn has 1 minus n. So again this generates positive quantities, this generates negative quantities, and the integral over here is both taken in anti-clockwise direction. So how do we measure the curve? The curve is measured in the anti-clockwise direction. Now we are going to represent the function as a series representation, so that I will be able to expand it in the neighborhood points. So I need to know what is going to be the binomial series, which is the base for all of it, which takes the formula 1 plus x power minus 1 is 1 minus x plus x square minus x cube and so on, and 1 minus x power minus 1 is 1 plus x square plus x cube and so on. So what is the difference we notice here? Here both of them are negative. Here one is positive, the other one is negative. Notice that if both of them are negative, then you can see that you have all terms to be positive. But if you have alternating sign in your expression, sorry, the power plus over here and minus over here, the series expansion also contains alternating sign with one positive, the other negative, one positive, another negative. And the primary thing which we need to keep in mind is that this binomial series is convergent for modulus of x less than 1. So whatever be the series expansion we are going to do, we will have to make sure that the modulus of the value is strictly less than 1. So we will try to apply the Laurent series to the function f of z is given as z square minus 1 by z plus 2 into z plus 3, which is going to be defined or expanded for 3 different zones. The first zone mod z less than 2, second zone 2 less than mod z less than 3, and the third zone which is mod z greater than 3. So this is going to be a part C question. The primary objective is to first evaluate this function as a partial fraction. So my step 1 will be splitting the function f of z, which is z square minus 1 divided by z plus 2 into z plus 3 as partial fraction. So once I am able to split, why the requirement for partial fraction? Because the terms are in product over here. I can expand them only independent term wise. If I want independently to split these factors, then the method is going to be partial fraction for me. Now the first caution which we will have to notice over here is I need a fraction, but we notice that z square is there in the numerator, z square is there in the denominator, which means numerator and denominator has the same power, in which case I will not be getting a fraction, I will be getting a whole number. So what happens is when I split this equivalent term as factors as fraction, then give one independent variable or a constant for the estimation. Next go with b divided by z plus 2 and c divided by z plus 3. Normally we have a tendency of splitting one constant for the first factor and the second constant for the second factor, but we will try to ignore the numerator in many of the cases. So don't ignore the numerator. If numerator and denominator are of the same power, then give one more constant to be evaluated for. So I have z square minus 1 to be equal to a into the factors are z plus 2 into z plus 3 plus b times the missing factor is z plus 3 plus c times it is z plus 2. So my target is now to find values of a, b and c. So we will quickly move on to the next thing. Z square minus 1 to be equal to z plus 2, z plus 3 plus b into z plus 3, c into z plus 2. Now let me substitute z is equal to minus 2, so I will have minus 2 the whole square minus 1. If I put minus 2, this part will vanish, this part will vanish. I will have my b to be equal to minus 2 plus 3. So this is going to be 4 minus 1 is equal to b times of 3 minus 2 is going to be 1. So this gives me b to be equal to 3. Now move on to the next factor. Put z plus 3 equal to 0 or z is equal to minus 3. So I will have minus 3 the whole square plus 1, sorry minus 1 to be equal to, this contains z plus 3, so this will vanish, this contains z plus 3, so this will vanish. So the remaining term will be z plus 2 with c as the coefficient. So this makes it as 9 minus 1 equal to c into, this now takes the value minus 3 plus 2 will be equal to minus 1. So 8 equal to minus c, which implies c equal to minus 8. Now I have got the values for b and c. The leftover element is going to be a. How to get it? Only two factors were there. We substitute for both the factors. So now I can go for comparing the coefficients of your powers of z. So notice that a is going to be z into z, so z square is going to be the maximum power degree. Okay, so when I compare z square on both sides, then what is the coefficient of z square over here? It is going to be equal to 1. So 1 is equal to z square's coefficient over here is going to be a. Does b has a z square? No, so this becomes 0. Does c has a z square? No, so this becomes 0. Hence I have the value of a to be equal to 1. So I have estimated all the three constants a, b and c. Now put it back in your fraction so that we have this to be equal to z square minus 1 by z plus 2 into z plus 3 will be equal to a, which is 1, plus b was equal to 3, so 3 divided by z plus 2 minus the next quantity was 8, so 8 divided by z plus 3. Now my step 1, which is going to be the partial fraction, is going to be ready for me. Now I will have to expand each of these in the three different zones which has been given to me. Let me consider the first zone, mod z less than 2. So what I have, my first boundary is mod z less than 2. My idea is always the series has to be mod z less than 1. It has to be less than 1. This is less than 2. So how to make it? So divide by 2 so that it becomes mod z by 2 is less than 1. I'll have to make sure I have factors of this kind so that the series is going to be less than 1 and hence it is going to be convergent. So I can write the first term. It doesn't have a denominator, so leave it as such. 3 is here in the numerator. I want z by 2 format. I need a z by 2 format means you'll have to think what can be taken outside as common. When I take 2 common outside as common, I will be left out with 1 plus z by 2. So now see, automatically we have the factor z by 2. But if I am going to take z outside, what will happen? I will have 1 divided by 2 divided by z. Is this the required format? No, this is going to be wrong. So keep in mind, I have to always make it as less than 1. So on which variable when picked outside as common can give me the term is what I need to check for. This is the only point which we need to be very cautious when expanding in your Laurent series. So the second term will be 8 divided by, I have a 3. I know that 1 by 2 is going to be less than 1. What can you say about 1 by 3? Yes, 1 by 3 is still less than 1. So this says that mod z by 3 will still be less than 1. So now tell me, I need a z by 3 format. So what will be the term that I will have to pull outside? Yes, you are right. I will have to pull 3 outside. So this gives me 1 plus z divided by 3. So now I have had a z by 3 format. So I now rewrite this as, take it to the numerator, 1 plus z divided by 2 the whole inverse minus 8 by 3 times 1 plus z by 3 the whole inverse. Now we can see one term is positive, the other term is negative. One term is positive, the other term is negative. So what will happen? I will have this as 1 plus 3 by 2 into the series which gets generated is 1 minus z by 2 plus z by 2 the whole square minus z by 2 the whole cube and so on. What is the next term that gets generated? 8 divided by 3 times. So again we see that one is positive, the other one is negative, so you need alternatively positive and negative. So z by 3 plus z by 3 the whole square minus z by 3 the whole cube and so on. So final stage, I need to express them as a series. So I can write summation n varying from, it starts with 1, so the power is going to be 0, 1, 2, 3 and so on. So n varies from 0 to infinity. I have z divided by 2 the whole to the power of n. This will now generate the terms. But now I need to generate also alternatively positive and negative series. How to take care of it? just fix a -1 the whole power n. So as my n varies, this also series varies as positive, negative and so on. So this -1 power n will take care of the alternative positive and negative series, and the next term will be -8 by 3. So I can write this as summation n varying from 0 to infinity z by 3 the whole to the power of n. Again, this contains an alternative positive and negative terms, so multiply it with -1 by n. We can notice that this doesn't contain any powers of z, so it is a mere constant. This contains z to the power of n, which means it contains positive powers of z. So what do you can tell the term that contains positive powers? You call it to be a regular part. And this also contains z to the power of n in the positive terms, so this also becomes your regular part. So this problem as such in the expansion doesn't contain a principal part but contains only a regular part. Okay, so our first zone is going to be over. Now let me go on to check the second zone. What is the second zone for me? 2 less than mod z less than 3. So we will have the same expansion, but we will have to go for the zone number 2, which is 2 less than mod z less than 3. I'll have to consider the fraction a, which was 1 plus, what is my function f of z? Now 1 plus the value was 3 by 2 into 1 divided by 3 divided by z plus 2, 3 divided by this was z plus 2, and the third factor was -8 by z plus 3, -8 by z plus 3. Now the function is the same, but what has changed? The region has changed for me. Now let me consider the first part, which says 2 less than mod z. I need to have always mod z to be less than 1. The quantity has to be less than 1. If I want less than 1, so what I'll have to do? I know 2 by mod z will be less than 1. So I need to bring the fraction to the format 2 by z. Now considering the second part, what do I have? Mod z is less than 3. I want it to be less than 1. So mod z divided by 3 will be less than 1. So I also have to make sure that I have the portion as z by 3. Notice z is there in the denominator here, z is there in the numerator here. So I need to adjust the terms accordingly over here. I need 2 by z. So tell me what will be picked outside. So when I pick z outside, I will have 1 plus 2 divided by z. So I get it of this format. I have -8. I need z by 3. So how will I get z by 3? I will have to pick 3 outside. So I will have 1 plus 3. So z divided by 3. So I have the required format now. I can expand this as a series by taking the quantity to the numerator as 1 plus 2 by z the whole power -1 -8 by 3 times 1 plus z by 3 the whole power -1. So it is 1 plus 3 by z, expand plus minus, so alternatively positive and negative series, positive negative 2 by z plus 2 by z the whole square minus 2 by z the whole cube, and so on. And the next term is -8 by 3. This term is again positive and negative, so 1 minus z by 3 power 1 plus z by 3 power 2 minus z by 3 power 3, and so on. So now I have the expansion. Now I need to write it in the formation of summation. How can I write it in the format of summation? I can do this as summation n varying from 0 to infinity 2 by z the whole to the power of n. So this is my expansion, but I need alternatively positive and negative sign. So plus add multiply it by a minus 1 power n. And how about the next series? This is summation n varying from 0 to infinity. The series is generated by z by 3 the whole to the power of n. Again a positive and negative term, so multiply it with minus 1 power n. Therefore the function f of z is expressed as 1 plus 3 by z times summation n varying from 0 to infinity 2 divided by z the whole to the power of n into minus 1 power n minus 8 divided by 3 summation n varying from 0 to infinity. You have this to be equal to z by 3 the whole to the power of n and a minus 1 power n. Notice these terms contain z in the denominator, so it contains negative powers of z, and you call this to be a principal part. Now this contains z in my numerator, so I have positive powers of z, which makes me refer this part as a regular part. So this second region of 2 less than mod z less than 3 contains both a principal part as well as a regular part. So now moving on to the last stage, I want it to be extended in the zone of mod z greater than 3. So we will complete the problem by expanding it in the third zone, which is given by mod z greater than 3. So the function f of z is 1 plus 3 divided by z plus 2 minus 8 divided by z plus 3. Now this has to be expanded in this zone. So let me put it in the reverse order. 3 is less than mod z. I need to know that always I need a format less than 1. So 3 divided by mod z will be less than 1. So if 3 is less than 1, then what can you say about 2 by mod z? This will be 3 is less, so 2 is a still lesser number, so you will have 2 by mod z to be still lesser than 1. So I can expand it in the zone of such an expression. So keep in mind what we need is 3 divided by z and 2 divided by z. If I want 2 divided by z, what has to be taken outside? Take your z outside, so this becomes 1 plus 2 divided by z minus 8. Now I need 3 divided by z, which has to be taken outside. Take your z outside, so I have 1 plus 3 divided by z. So now I have it of the required format. Expand them. So take it to the numerator, write it with the power minus 1 minus 8 by z 1 plus 3 by z whole power minus 1. I can give the expression as 1 minus 2 by z plus 2 by z the whole square minus 2 by z the whole cube, and so on. And the next term to be minus 8 by z 1, again positive and negative, 3 by z plus 3 by z the whole square minus 3 by z the whole cube, and so on. So now let me finalize this. So how can I write the term 2 as? I can write this as summation. This is 2 by z, n varying from 0 to infinity, 2 by z the whole to the power of n. That will take care of the terms. But about the alternating terms, so I put an extra minus 1 power n, and that is going to be a 3 by 2 in front. About the 3 by z in front. Now coming to the second term, I have minus 8 by z. How can I write this expression as? N varying from 0 to infinity. This makes it as 3 by z the whole to the power of n, and the alternating term with minus 1 to the power of n. There is going to be 1 in front. So my function f of z is now given this series expression, which is called as the Laurent series. This contains z to the power of n in the denominator, z to the power of n in the denominator. So this is my principal part again, and this is going to be a principal part again. So this portion doesn't contain a regular part. So this will be the way in which a Laurent series can be expressed or expanded as a series in the various zones of expression. The only thing we need to keep in mind is going to be, we always have to make the quantity less than 1. If it has to be made less than 1, you make sure which term has to be taken outside to get the required expression. Thank you.